Open the 11 linear SimExpert file. Open the Materials and Properties tab. Click on Isotropic in the Materials group. Change the name to steel. For Young's modulus, input 207 gigapascal. For Poisson's ratio, input 0.3. Click on OK. Click Solid in the 3D Properties group. For entities, deselect all the filters except the part filter. Click on the bracket. For material, click on the drop-down menu and select steel. Click on Apply. For entities, deselect all the filters except the parts filter. Click on the base plate. Click on OK. In order to run a contact analysis, you need to define deformable contact bodies. To do this, click on Deformable Contact Bodies in the Contact group. For pick entities, select the ladder bracket and click on Apply. Select the base plate and click on OK. Next, we need to create a contact table that defines the contact relationship between the parts. Click on Tables in the Contact group. Click on Glue All and deactivate Diagonal. Click on OK. For more on contact tables, view Supplementary 7. Right-click on File Set in the Model Browser and select Create New Nastran Job. Click the file icon next to Solver Input File and save where you can locate it later. Right-click on Solver Control in the Model Browser and click on Properties. Click on Contact Separation Parameters. Select Stresses in the Separation Criterion drop-down menu and click on Apply. Click on Output File Properties. Select Master Only in the Nastran DB Options drop-down menu. Click on Apply and close the form. Right-click on Output Request in the Model Browser. In Nodal Output Request, select Create Contact Output Request. Click on OK. Right-click on LBC Container. Click on Select Contact Table. Click on the drop-down menu and select the contact table. Right-click on New Job and select Run. Open the file where you saved your Nastran job and monitor the FO6 file. Search for End of Job to determine whether the job is done. Once the solver is done, attach the results. Open the Results tab and select Deformation. Open SC1. Click on Static Subcase and select Displacements Translational. Click on Update. We can now see how the part has deformed. Remember that this deformation is exaggerated. The base plate is not bent because it was completely fixed on one side. However, the elements connected to the bracket have deformed. This is to be expected because the bracket is glued to the base plate. To see this deformation more clearly, we can isolate the elements at the contact surface. Click on Target Entities tab. In the Target Entities drop-down menu, select Elements. Click on Hide and then hold in Control and select the element shown. Click on Update. You can now see that these elements have deformed in the direction of the load. They have remained connected to the bracket. To only view these elements, select the Show Hide 3D Finite Elements. Note that you must hide all the geometry. Click on Hide and Show 3D Elements. Clear the elements and select the one shown. Click on Update and hide 3D elements. We can now see how the base plate elements follow the bracket elements. Click on Hide and Show 3D Elements. Click on Plot Data and select Fringe in the Type drop-down menu. Select SC1 and choose Stress Tensor and von Mises. Click on Update. We can now see the stress distribution caused by the load. Click on Animation Settings and animate the results. Note that there is some stress distributed to the base plate. This tutorial was proudly brought to you by Estech.